Hello. There have been some questions on lesson 4.6, question number 29. And so I thought this would be a great space to just create a video so I can support you all on this. So we are looking at exponential and logarithmic functions, and in particular, these growth functions here. So it says pesticides decay at different rates depending on the pH level of the water that is used to mix the pesticide solution. The pH scale measures the acidity of the solution. The lower the pH value, the more acidic the solution. So just like I have these little test strips here, these are the different pHs. So these lower pHs are going to be more acidic, and these higher pHs are going to be more basic. So it says when mixed with water that has a pH of 6.0, the pesticide chemical known as malathion has a half-life of 8 days. So let's just write down what that tells us. So the one that has pH 6.0, half-life is 8 days. That means every 8 days, half of the amount is remaining. However, if it is mixed with water that has a pH of 7.0, the half-life decreases to 3 days. So if it's mixed with water that has a pH of 7.0, the half-life is 3 days. So that means it decays quicker with the higher the pH. Okay, so part A says assume that the initial amount of malathion is 5 milligrams. Find an exponential function of the form A equals A times e to the kt that gives the amount of malathion that remains after t days if it is mixed with water that has a pH of 6.0. Okay, so part A is we want to come up with this function here such that A, our starting value, they said, is starting with 5 milligrams. Okay. And it's for the 6.0. So we're using this scenario here where the half-life is 8 days. Okay, so we know that T is 8 days. So I'm starting with 5 milligrams, e to the k, and in 8 days, so I'm going to put my time at 8 days. That means at 8 days, my output is going to be half of 5, so 2.5. So now to solve for k. So you can kind of see that 2.5 divided by 5 gets us to the half-life. Okay, so that's where this can become 0.5 e to the 8k. I'm just going to put the 8 in front of there. So as long as you know that it's the half-life that we're talking about, this ratio will always just be 0.5. So if I started with 10 of these milligrams, then this would be 5, because after 8 days, it's going to be in half. So this is 0.5. So now I'm just going to solve for k by taking the natural log of both sides. So that goes to 1. So this becomes 8k. And this is just the natural log of 0.5. And so to solve for k, we can take a natural log divided of 0.5 divided by 8, and we get k. And I will show you this in my Desmos here. So that's right here. Ln of 0.5 divided by 8 is a negative 0.87. Okay, so let's go back to my paper. So the equation for the pH of 6.0 is going to be A e to the negative 0.087 t. And for this particular, it's we're going to replace A with 5 because we had, this is when this scenario only happens for K when A is 5. Okay, then we're going to do the same thing in part B for the malathion that's mixed with the 7.0 water, and that has a half-life of 3 days. So that's going to be, again, if we're starting with 3, sorry, we're starting with 5, but we're still starting with 5 milligrams, and we're going to use the pH of half-life is 3, so that means we'll be at 2.5 milligrams, so 0.5 equals e to the k times 3. And then again, if I take the natural log of both sides, and I can divide by 3, then my k for this situation equals negative 0.23. So this function, we'll call this one b, is 5e to the negative 0.23 t. Then C says, how long will it take for the amount of malathion in each of the solutions to decay to 3 milligrams? So instead of decaying by half, we're decaying by 3/5. So I'm going to do this pH 6.0. So that means I want to be at 3 milligrams. I'm starting with 5, e to the negative 0.087. I'm going to solve for t. So 3/5 equals e to the negative 0.087 t. And again, I'm going to take the natural log of both sides. So, and I'm just going to keep filling in this fraction here, and I'm going to do it all in Desmos at once because it'll be the most accurate. So then to solve for t, I'm going to divide natural log of 3/5 divided by the negative 0.087, and that'll be my time. And so we're going to go to Desmos right now and do that calculation. And here's that calculation in Desmos, and it's about 5.87 days. Okay, and then likewise, we're going to do the same. So then we're going to do the same with mixing of the water that has a pH of 7.0. And here's that formula. So, and so this becomes, it's just going to end up being the same thing, but it's just going to be the natural log of 3/5 divided by a negative 0.23 is the time. And so that one comes out to be about 2.21 days. And so part D says, if the malathion is to be stored for a few days before use, which of the two solutions would be more effective and why? And on that one, we would choose the pH of 60 because it takes longer. The pH of 6.0, sorry, takes longer. And so if it's going to sit there already, we want it to last longer. So that would be the one that lasts longer. And then it's just graphing the two there. So let me know if you have any other questions.